My area is the motor area.
My videos are on the neurons and the new brain.
I am talking about nervous system and old brain. And I am not talking about my brain. I am talking about the decision maker in the brain.
And I will be discussing the endocrine system and joined with Martha, the old brain.
In this video, I'm going to be talking about the structure of a neuron. Neurons are the building block of our nervous system and have many different parts. The first part are the dendrites. The dendrites are tree-like branches that receive chemical messages from other neurons. From them are traveled to the soma, or cell body, and the nucleus. They do not play a big part in the chemical message. What they do is maintain the function of their neuron. The axon, which sends the message to the terminal buttons, sometimes is covered by a fatty substance known as the myelin sheath. The myelin sheath acts as an insulator and allows the message to be sent much faster to the terminal endings. The terminal endings, also known as the synapse, carries the message to the next neuron where the process starts all over again.
A mirror neuron is fired when a person observes a certain behavior or enacts the same behavior. For instance, Sean imitated Abigail after watching her dance, acting as a mirror neuron. This skit is a demonstration on how neurotransmitters communicate chemical messages. The axon, which produces and stores chemical transmitters, travels through the synapse to the dendrite at the receptor site. The neurotransmitters carry two types of messages. Excitatory message, which means fire, or an inhibitory message, which means don't fire. The inhibitory message, which was not received, is now traveling in the synapse, where it is recycled in the uptake and used again in the same form.
Central and peripheral nervous system. The nervous system is divided into two main parts, central nervous system and peripheral nervous system. The central system is composed of the brain and the spinal cord. The spinal cord is the primary means to transmitting messages between the brain and the rest of the body. However, the spinal cord is not just communication channel. It also controls some simple behaviors on its own, without any help from the brain and stimulus. At work is also when you touch a hot stove and immediately withdraw your hand. The initial withdrawal is direct only by nerves in the spinal cord.
The endocrine is similar to the nervous system. The nervous system sends electrical messages to control and coordinate the body. The endocrine system has a similar job, but rather uses chemicals to communicate. These chemicals are known as hormones. Hormones are chemical messengers released into the blood that act through receptors to cause a change in the target cell. In other words, they transfer information from one set of cells to another to coordinate the functions of different parts of the body. The major glands of the endocrine system are the hypothalamus, the pituitary gland, pineal gland, the thyroid, and the parathyroid gland, adrenals, the reproductive organs, which are the ovaries and testes. The pancreas is also part of the system. It has a role in hormone production as well as in digestion. The hypothalamus and the pituitary gland are the principal organizers of the endocrine system. The hypothalamus is part of the brain and is directly connected to the pituitary gland. This part of the brain is important in regulation of satiety, metabolism, and body temperature. In addition, it secretes hormones that stimulate or suppress the release of hormones in the pituitary gland. The pituitary has two quite distinct parts. The posterior pituitary, which is an extension of nerve cells from the hypothalamus, and the anterior pituitary gland, which is linked by blood vessels from the hypothalamus. The hypothalamus controls the function of both the anterior and posterior pituitary, but achieves them in different ways. The hormones secreted by the posterior pituitary are synthesized in nerve cells in the hypothalamus and transported along axons to the posterior pituitary, from which they are simply released from the nerve terminals. The anterior pituitary secretes by releasing and inhibitory hormones which travel from the hypothalamus to the anterior pituitary in a network of blood vessels called a portal circulation, regulated by the hypothalamus. So it can be seen that the hypothalamus and the pituitary are the master controllers of several completely independent endocrine systems as the pituitary and the hypothalamus. Another endocrine gland, the thyroid gland, is located in the lower front part of the neck. It produces thyroid hormones that regulate the body's metabolism. It also plays a role in the bone growth and development of the brain and nervous system in children. The pituitary gland controls the release of thyroid hormones. Thyroid hormones also help maintain normal blood pressure, heart rate, digestion, muscle tone, and reproductive functions. Parathyroid glands are two pairs of small glands embedded in the surface of the thyroid gland, one pair on each side. They release parathyroid hormone, which plays a role in regulating calcium levels in the blood and bone metabolism. Another endocrine gland, the pancreas, is an elongated organ located toward the back of the abdomen behind the stomach. Do you know what's the central core?
Yes, central core is the old brain, which controls some basic functions like sleeping or eating.
Another component of the old brain, the cerebellum, is involved in the coordination of voluntary motor movement, balance and equilibrium, and muscle tone. It is located just above the brainstem and towards the back of the brain. Cerebellar injury results in movements that are slow and uncoordinated. Individuals with cerebellar lesions tend to sway and stagger when walking, such as someone does when under the influence of alcohol.
The reticular formation is a comprehensive network of nerves that is found in the central area of the brainstem, situated between the top of the brain stem and the bottom area of midbrain. The formation helps to automatically regulate the beating of the heart, breathing and respiration functions, and the process of the digesting food in the gastrointestinal tract. The thalamus is part of the brain, located in the middle of the central core, which modulates arousal mechanisms, maintains alertness, and directs attention to sensory events.
The limbic system is a set of evolutionarily primitive brain structures located on top of the brainstem and buried under the cortex. Limbic system structures are involved in many of our emotions and motivations, particularly those that are related to survival. Another component of the old brain, the tiny hypothalamus, serves as the health maintenance organization of the body, regulating its homeostasis or stable state of equilibrium. The hypothalamus also generates behaviors involved in eating, drinking, general arousal, rage, aggression, embarrassment, escape from danger, pleasure, and copulation.
Today I will talk to you about the motor, the sensory, and the association of the cortex. By using the Nintendo Wii, my sister here, she would be demonstrating to you about the voluntary movement that sends messages from the brain to the body. Hi.
I'm here to give you a short demonstration on voluntary movement by playing the Wii game. And basically, you just hold the Wii remote down securely in your hand and you're going to press A and B. So I'm going to show you a preview how that works.
Now you just witnessed the motor area that is part of the cortex that plays a large responsibility for the body voluntary movement. The sensory area, which is located in the parietal lobe, helps guide and direct the senses, which allows the body to understand touch and pressure. Right here is my little brother. He's blindsided, by the way. He will identify these two items using just.
Say what's up, Junior? What's up? Have you heard the song before?
Now who's that?
Justin Bieber. How you got it up?
I heard of him, but just showing you the association area by memorizing the song by using my thought, language, speech, and memory. Alright, got it.
In this scene, Abigail is using her frontal lobe, which is responsible for her creative thought. The frontal lobe, which is located around her forehead, is responsible for emotions, reasoning, movement, and parts of speech. It also helps us in activities such as judgment, problem solving, and creativity. During the sibling spat, Abigail's parietal lobe went into action when Sean hit her, sending a message saying, ouch. The parietal lobe, which is located behind the frontal lobe, is responsible for touch, temperature, taste, pressure, and pain. As Abigail searches for a tangerine, she is using her occipital lobe to correctly identify which item is which. The occipital lobe, which is located at the back of the brain, allows our brain to recognize different objects, and is also responsible for our vision. As the music travels from his ears to his temporal lobe, it processes the auditory stimuli, creating him to dance. The temporal lobe, which is located on either side of our brain, is responsible for interpreting and processing auditory stimuli, as well as hearing, memory, and meaning.